All right, so here's an example of a double inequality that we're going to solve. This one's a little bit more complex. We have a couple different ways of solving double inequalities depending on how they look like. Now, looking at this guy, if we see our two inequalities, we can see that there are variables in each of the three sections. So when you have variables in every section, you kind of have to split this up into two separate inequalities and treat this like a typical conjunction problem. So the way you do that is you kind of take a look, and it's kind of a Venn diagram situation. So I'm looking at this inequality, 4b plus 8 is less than or equal to negative 12b minus 14, and I'm going to treat that as one inequality. So essentially I'm breaking this out into two pieces. And then, like I said, we kind of Venn diagram it. So we take that middle piece, and this is our second inequality. So this would be our second part of our and situation. So then we have and negative 12b minus 14 is less than or equal to 14 minus 5b. And now, because we have gone over this multiple times, this is now really just basic two-step inequality, or basic inequality where we have variables on both sides of the inequality symbol. So you use your properties of equality as typical. So first, in our first inequality, I'm going to consolidate my variables by combining like terms using the addition property of equality. I end up with 16b plus 18 is less than or equal to negative 14. Next step, we are using the subtraction property of equality to start isolating that variable. They cancel out, zero out, don't need to worry about them. I bring down 16b to the next step of my inequality. Negative 14 minus 18 is negative 32. Again, be careful of your operations with integers that can trip you up even if you have everything else going right. So make sure you're doing that correctly, following your properties. Division property of equality, because 16 times b is reversed by dividing by 16. And now I end up with b is less than or equal to negative 2. So that's our first inequality, the solution to one end of this. My other inequality, same deal. This time I'm going to be adding the 12b. This prevents me from having to divide by a negative at the end of this whole situation. Combining my like terms, they get to cancel out. I have negative 14 is less than or equal to 14. And now this is positive 7b, because negative 5 plus 12 is 7. I subtract my 14 from my negative 14, remembering to make sure I'm using good integer math, integer computation. Negative 14 minus 14 is negative 28, less than or equal to 7b. And my last step is dividing by 7. On both sides, negative 28 divided by 7 is negative 4 is less than or equal to b. Once again, we want to pay attention to the fact that we have b on the right. So if I want to kind of see this in the same light and be able to compare it, I have to switch the direction of, I'm switching places b and negative 4, but I have to also switch the inequality. So instead of less than or equal to, it's greater than or equal to. That relationship needs to remain the same. So it is b is greater than negative 4. And in general, we now know, okay, it's between negative 4 and negative 2. So if I'm thinking about making my compound inequality here, we would have b in the middle. It is greater than negative 4. So if negative 4 is less than b, which is less than negative 2, it is between those two numbers. So when I'm graphing this, we've gone over what this actually looks like. It is a conjunction of the two set inequalities. B is greater than negative 4. B is less than negative 2. It is in between those two. So rather than graphing both of them and then graphing the conjunction, we can just graph the conjunction. So These are both closed circles because they include our target numbers in the solution, and then we are just connecting them because we have the conjunction. It needs to be greater than -4 and less than -2, telling us it must be between those two values, our solution set.